Now that you've had a chance to get an understanding of how inverse trigonometric functions work, especially which quadrants they lie in, the angle parts of them, we're going to look at some more advanced computations as well as some application problems that involve inverse trigonometric functions. So first we're going to solve a problem that involves computing a quantity that contains both a trigonometric and an inverse trigonometric functions. And then we're going to do an application problem where the inverse trigonometric functions just kind of show up. All right, so recall the quantity sine of arc cosine of 3/8. And this is one of the ones that we kind of struggled with during the in-class activities. And let's see some of the techniques that we use to actually do this computation. How are we going to compute this? Well, one thing is we're going to separate dealing with the sine part of that problem and the arc cosine part of that problem. And in fact, we're first going to focus on the arc cosine part of the problem so we can understand the angle. And then once we understand the angle, finding sine of the angle is just kind of figuring out what the right triangle is. So what we're going to do is concentrate on arc cosine of 3/8. And since that is an angle, we're going to set it equal to theta so it looks more like an angle. Plus, it gives us an equation we can deal with. So if we want to do the same thing to both sides of the equation, we can. All right, so our goal is to find sine of arc cosine of 3/8, which means we want to find sine of theta. So what can we say about theta which equals arc cosine of 3/8? Well, we'd like to understand it's an arc cos of a ratio, right? So we want to understand it in terms of the original function that inverse function came from, which was cosine, right? So if we were to take cosine of both sides, that would give us an equation that we were more comfortable with. On the left-hand side, we're going to get cosine of theta when we do that. On the right side, when we take cosine of arc cosine of 3/8, the cosine and arc cosine are inverse functions. They're going to cancel each other out. We're just going to get 3/8. So what we're looking for is an angle, theta, where cosine of theta equals 3/8. But remember, theta is the arc cosine of a ratio, which means that it can only be in quadrant 1 and quadrant 2. Remember, arc cosine could only be between 0 and either pi radians or 180 degrees. And now we got to figure out where it is. Well, let's see. Let's pretend for a while. Let's see what angles look like in quadrant 2. The cosine of those angles, remember, cosine is based on the x-coordinate of our points on our unit circle. So if we're in quadrant 2, that means our x-coordinate, our cosine of theta, is going to be negative. Well, our cosine theta was 3/8, which was positive, which means we got to be in quadrant 1. So let's eliminate that asterisk in quadrant 2. Quadrant 1, where that 1 asterisk remains, that is where our triangle is going to be. Now we can actually start drawing our triangle. Remember, the cosine of our angle is 3/8, which means probably the most convenient way of doing that is having the adjacent side be 3, the hypotenuse be 8. So when we divide the adjacent over the hypotenuse, we get 3/8, which is what we want. Now we're looking ahead. We want to find sine of theta, right? So it's going to be helpful to figure out what the opposite side of that triangle is going to be. Well, we don't know what it is yet, so I'm going to give it a name. I'm going to call it A. And because we have a right triangle, once again, Pythagorean theorem is going to come to our rescue. We get 3 squared plus a squared equals 8 squared. If we solve for 8 squared, we get a squared. If we solve for a squared, we get a squared equals 55. And if we solve for a, well, we got to be careful because a could be positive square root of 55 or a negative square root of 55. And we really got to look at the situation in order to figure out which one it is. Well, you can kind of see from the picture that our a is our y-coordinate. And since we're in quadrant 1, our y-coordinate is going to be positive, which means that we can't have the negative square root. We have to have the positive one. So a has to be square root of 55. I'm going to go ahead and put that one in there. And now we're in perfectly good situation. Remember, we're looking for sine of arc cosine of 3/8, which, if you look above, that is simply sine of theta. We know what sine of theta is. That is just the opposite side divided by the hypotenuse. Square root of 55 divided by 8. And that solves our problem. All right, so our next problem that we're going to work on is an application. And on this one, we got JoJo out Not worried so much about any of their business ventures this time. They're out on vacation going for a hike. They're standing at the edge of a creek that is 10 feet wide and flows in a straight line. And Jojo sees one of their friends standing directly across the creek from them, waving hi. And then 7 feet down on that same other side of the creek from them is another friend, 7 feet down. So the question is, what is the angle Jojo makes when turning from one friend to the other? So basically we're thinking Jojo's going to wave at one friend, then turn a certain angle and wave at another friend. We want to find out what that angle is. Well, let's draw a picture of the situation. Well, there's Jojo on one side of the creek. There's the friend directly on the other side of the creek, and another friend a little ways down, also on the other side of the creek. Now remember, the creek is 10 feet wide, so if we want to measure the distance between Jojo and the first friend, that's going to be 10 feet, and we draw a little line there, and that makes a right angle with the other side of the river. Now remember, the two friends are 7 feet apart, and so between the three friends, we've got a right triangle where two of those sides of those triangles, the two non-hypotenuse sides, are 7 feet and 10 feet. And the angle we want, the one where Jojo turns from one friend to the other, is going to be that angle theta right there. Well, what do we know about theta? Well, we know something about the opposite and the adjacent side of that right triangle. So that looks like we want to look at the tangent function. And if we look at the tangent function, well, tangent of theta is going to be the opposite over the adjacent. That is going to be 7 over 10. And if we want to know literally what theta is, then what we want to do is take the arctangent of both sides, and we end up with theta equals arctangent of 7/10. If we take the arctangent of the left-hand side, we get arctangent of tangent of theta. The arctangent and tangent cancel each other out to give us theta. And then if we take the arctangent of the right-hand side, we just get arctangent of 7/10. Now, arctangent of 7/10 is something that can actually be computed. You can put it into your calculator. You can put it into Wolfram Alpha. Even Desmos will do it for you. And that gives you, if you want radians, about 0.6107 radians. If you want it in degrees, it's approximately 35 degrees. So this gives you an idea of what kind of computations and applications that we can solve using inverse trigonometric functions. And so we have two sets of activities, one for each of those possible types of problems. One's called advanced computations. That's going to be the same type of computations as we did for sine of arc cosine of 3/8. And then the other one is applications of inverse trigonometric functions. That's going to be one that's more like the river problem. And both of those PDF files are included with this video, and so you should be ready to work on those.